Okay, so I want to talk a little bit about making the antenna right now. First, I'm going to show you an antenna that I've already made. I built this antenna out of a hula hoop and used the hoop as the frame for the antenna. I also used a type of cable called sprinkler cable or sprinkler wire. I also found that the hoop that I used was not large enough to go to feed the wire through the interior of the hoop. So even though part of it is going through the hoop, as you can see in here, the rest of it I had to use the frame as the guide and zip tie to the frame itself. So you can see I've kind of just wrapped it around and then used these zip ties to create a stronger connection to the frame. This hoop also, in order to break open, it had two notches on the top and the bottom in order to make a full loop around. So I had to cut both sides, which made it not as stable for maintaining a hoop shape. So I'm using this like tension. I'm creating some tension with this string here. Because I use sprinkler wire, I wanted to maximize the number of turns around the loop. And in order to do that, I had to connect the wire from the inside to a different wire. Because there's 5 wires inside of it, I was able to turn a 50-foot piece of wire into a 250-foot piece of wire just by kind of connecting the individual wires between themselves to just make one long loop that goes all the way around. You can also see here's my audio output. So this is the jack that I used. I also soldered these connections too, but originally they were just twisted. And then I also used some heat shrink tubing to cover them so they wouldn't accidentally short between themselves if they came too close. So that's one example of a hoop. I have another one that I want to show you. Instead of a round loop, I was going to make a square-shaped antenna. It's still considered a loop, even though it's only got 4 points, so that I could wrap the wire around each corner of the cross. And I just had some wood hanging around. I had this old kind of board, 4 little blocks of wood, and I was able to use zip ties through the board to connect the wood to there in kind of the shape I needed. I also, in the corners, left a little bit of space so that the wire kind of won't fall off the back, but I might even need to make more space. I found a guide that recommended roughly 60 centimeters for each side of the square. It's a little bit rectangular, but I think that's okay. And it's also slightly less than 60 centimeters per side, but I think that's okay as well. I'm going to be using this magnet wire. So let's get started with wrapping it. I'm going to need to leave one part of the wire near whatever side that I'm planning on ending it. Put it through this hole in the bottom, which seems about a good starting point. Some electrical tape. And now I can hold it a little more taut. So I'm going to start wrapping it. Here, I'm going to feed it through the bottom. The next step is going to be hooking up to my audio input. So first I'll feed this one also through one of the holes. I'm going to turn it onto this side. This is the input jack I'm going to use. Hopefully you can see it. With magnet wire, so that the wires don't short when touching each other, there's this thin coating of enamel on the wire itself. That's this like reddish coat. And in order to connect it, have it connect properly with the contacts on here, you need to scrape off this enamel. So just get something sharp and try to rub it off so that it's just raw copper, no coating on the wire before you try to connect it to your audio pin. Here I'm just using an old metal ruler that has a sharp edge on it that I can just scrape with. So from plugging this in, I noticed that this bottom one is the one that I'm going to want to contact, and then this back one is the other one I'm going to want to contact. Looks like I can also use this side one. This side. I just made some loops around the little coils, but it's attached now. You want to make sure that the copper's in contact with the coil, and make sure that the two wires aren't in touch with each other. And then there's some space between them. I need to attach this somehow. Looks like I could probably do it with the zip tie. I'm just gonna connect this here. So that seems like it's plugged in pretty well. And the next step is testing it out. So to test it out, I'm going to have a cable to plug it in, have my audio recorder, and I'm going to listen with some headphones in to see what I can hear. And right now we're not going to pick up, really, you might pick up a little bit of natural radio, but mostly this is going to probably pick up electrical interference from nearby. So it's probably going to pick that up, but that's kind of the idea, is if it's picking up that sort of stuff, then that means we are picking up signal. And I'm going to turn on the monitoring, and you can see there's a lot of signal there. This black bar means I'm getting a bunch of signal. I'll record this so I can play it back right now. So you're going to be hearing some humming noises. You can get some changes in the noise by moving it around. You can see, depending on where I'm pointing it, I'm getting a lot of different noises. Let's go over by the computer. That's usually a pretty good spot. Now I'm way down near the computer. I'm picking up a whole lot of weird stuff. Maybe it's from the fans in the computer. And you can see I'm picking up signal, and so that's a really good way to know that everything is working. So that's the general setup for winding it. Now for an exercise, what you can do is actually use this to go around your room and like check out and investigate all the different types of these humming noises are, and you can tell as you're angling it, moving it in different directions, that you're going to get different sounds, and you can find out where are the big sources of electromagnetic radiation within your room. And I think as a good exercise, we're gonna then try to create maps of everybody's rooms to compare, like what does the mapping look like? What is a different way to look at your room just through the electromagnetic spectrum, and how can you create a map of that?